So in question 30, estimate the x-coordinate of every turning point to determine if those coordinates are relative maxima or relative minima. So a turning point is exactly what it sounds like. It's where the graph is turning as you read it from left to right. So if we look at the question on 30, notice that if we go from left to right, that it's increasing, increasing, increasing until it gets to this point right here, then it starts to decrease, decrease, decrease. So the turning point is right here. And what is the x value of that turning point? So it looks like I have to go to the left 1, 2, 3, and probably about a half. So it has an x value of 3.5, negative 3.5, I should say. Then it also says to determine whether it's a maxima or a minima. So maxima means it is a high point, like the top of a hill, and a minima is a low point, like it's at the bottom of a hill. So that's at the top of a hill, so we would refer to that as a maxima. And then we continue on, so then we go down the hill until we reach the lowest point of the hill, which is right here. And that looks like it is about 2.5 points to the left. So we have x equals negative 2.5 is another turning point. And since that's a low point, that is a minima. And then we go back up the hill to the very top of the hill there. And we have another turning point. That is an x value of negative 1. Looks like it's 1 to the left. And that being the top of the hill is a maxima. And then we go back down to the bottom of the hill, and we have a minima located about x equals 1.5, or 1.5. So that is a minima because it's at the bottom of the hill. So all of that is part A, finding the maxima and the minima and the x values of the turning points. Part B is to estimate the x-coordinate of every zero. So the x-coordinate of every zero, remember the zeros is where it crosses the x-axis. So where does it cross the x-axis? So it looks like it crosses right there, about right there, and about right there. So go ahead and round those to the nearest half or the nearest whole number. So the first one, this one right here that I'm really highlighting, the first one there looks like it is about crossing the x-axis at just shy of negative 2. So let's just go ahead and call that x equals negative 1.9. So again, this is part B. So the x-coordinate of every zero would be x equal to negative 1.9 approximately. And then the next one right here is just to the left of 0, so let's just call it x equals, negative 0.2. Again, these are estimates. Excuse me. And then the last one right here looks like it is about 1, 2, 3, and we'll call that a half. So x equals 3.5 or 3.5 would be the third of the zeros. And so that's part B. Part C, determine the smallest possible degree of the function. So in the video that you watched, the degree is found by taking the number of turning points plus 1. That means it's going to be the exponent that you're going to see in the polynomial equation. And we already know it has 4 turning points because we figured that out in part A. So 4 turning points plus 1 gives you the degree of 5. This is a 5th degree polynomial. That's part C. And then part D is good old-fashioned find the domain and range. So notice that the graph is moving to the right and further to the left. It is moving slightly to the left, pretty slowly, but it is moving to the left. So since it's moving to the right and to the left forever and ever and ever, that means the domain is all real numbers. And then the range, since it is increasing to the right forever and ever and ever and decreasing to the left forever and ever and ever, that means the range is also all real numbers because it will continue to get higher and higher and higher and continue to get lower and lower and lower. So the range is high and low it is all real numbers as well. Now, that range is different than on 31. So just looking at the range for 31, notice that it is increasing on the right side and the left side, but unlike question 30, it is not decreasing forever. It is only increasing forever on both the right and the left. So the range on this one is going to be based upon what is the low y values of these W shapes down here at the bottom. So those looks like they have y values of -3, because it looks like that point is about 1.53, -3, and that's about -2.5, -3. But remember, the range is based upon the y values. So the range on 31 is going to be y is, since the rest of the graph is above that, y is greater than or equal to -3. So you would still do A, B, and C on that, but the range is a little bit different because it is increasing on both sides. The last two questions, the word problems, you get to use Desmos on those. So type those into Desmos, and then you'll answer the A, B, C, D questions just like you did on 30 through 35.